Hello, everyone. My name is Mr. Bryce. I'm with Susquehanna Valley High School here in Conklin, New York. There's my email address. We're doing Unit 6, pages 37 to 40 in this fantastic teacher's workbook. If you don't understand what I'm saying, of course, you can listen to him. We're doing Equations of a Circle, Common Core Algebra 2, the non-Regents version. So let's go. Various quadratic relationships can be placed into equations by knowing the locus definition of a relationship. This is the first time you've ever heard the word locus. Locus is talking about distance from something. We'll explore this for parabolas in a future lesson. This one, we're going to develop the equation of a circle by using the distance formula or the locus definition. Remember, I said locus means distance. Locus means distance. It's going to be the same distance away from something. So here is the distance formula. What? Distance between 2 points. The first point and the second point is given by distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Ooh, that's a brain full of cells right there. Wait a minute. Do you remember something like c squared equals a squared plus b squared? That's the Pythagorean theorem. A squared plus b squared equals c squared, if you want to say it that way. Well, this distance formula is derived from the Pythagorean theorem. A circle is a collection of all points that are a set distance, and that set distance is called the radius away from a point, its center. The circle shown below has a radius of 5, and the center point is 4, 2. An arbitrary point on the circle xy is marked. Okay, using the distance formula, which is good to use for this, show that the point 7 negative, show the point 7 negative 2 must lie on the circle. Verify it graphically. So let me see. Now we're thinking here, they gave us the fact that the distance, the radius, is 5. 5 equals the square root. Now, am I going to use the center as x2, y2? Or am I going to use the point 7, negative 2 as x2, y2? It doesn't matter. So I'm going to use x2 and y2 as that point right there. And the center is going to be x1, y1. So we plug in x2 from the equation, and that is 7 minus 4 squared plus y2 negative 2 minus 2 squared. And that should equal 5. So you notice that I do a little hanging at the end of the radical sign. That's just to show it closes. I haven't seen too many other people do that, but that's what I like. I crunch the numbers there, and I get this equals the square root of 25, which is 5. So it checks, must lie on it. It says use the distance formula. Now verify graphically. Okay, the point is 7, negative 2. I go over to the right 7, 2, 3, 4, 5, 6, 7, down 2. There it is graphically. This next question is saying letting x2, y2 equal xy and x1, y1 equaling the center of the circle, 4, 2, write the distance formula for all points in the circle. So what's saying is using variables and the center of the circle, write the distance formula for all points of this circle. Okay. I just checked the way that they wrote the formula. With this whole order of operations, we want to make sure that we do it their way because that's exactly what they're asking. So they want the x2 to come first, which is x, and then minus 4 squared plus y minus 2 squared. Write the distance formula for all points on the circle. There we go. Square both sides. D squared equals x minus 4 squared plus y minus 2 squared. Show algebraically that the point 1, negative 2 must also lie on this circle. Okay. For one thing, which equation do we want to use? Doesn't matter. Let's use the one that we just got in C, and we know that the distance is 5, so 5 squared must equal, so the point has to lie on the circle, 1 minus 4 squared plus negative 2 minus 2 squared. This is negative 3 squared plus negative 4 squared. That's 25. And so, don't forget to square our 5. 25 equals 25. It checks. You got it? Now let's take a look at the definition. The equation of a circle whose center is that, and whose radius is r, is given by this equation. The radius squared equals x minus the x point squared plus y minus the y coordinate squared. That's pretty important. We can find the center of a circle that way, and we can find all the points on the circle that way. Now, why is this important? Well, let's say that there's a fire in a garage and a paint can explodes. Using this, you can find where the paint can was when it exploded because of its radius. Now, what's so important about that? Well, certain thing, you can track where a fire was and how intense the fire was, how much pressure was in that paint can, everything like that. So there's a lot of things that investigators use that deals with this specific equation. Let's go on to exercise number 2. Which of the following equations would have a center of negative 3, 6, and a radius of 3? Well, you can eliminate 2 wrong answers immediately. I mean, within 3 seconds, you see which 2 we can eliminate. Which 2 can we eliminate? I'm saying that we're going to eliminate number 3 and number 4. Do you know why? It's because it says the radius is 3, and 3 squared is 9. That's why we can eliminate those 2 choices. So now let's look at these 2 over here. We know that it's negative 3 is the x value. So, let's see, x minus negative 3 is the same as x plus 3. So that one's wrong. And then the 6 is positive. So that's the right answer. Okay, we're rolling now. Let's take a look at the next page, see what's that. For each of the following circles, determine both its center and its radius. Now let's talk about something called vertex form of a parabola. So the vertex form of a parabola, f of x equals x minus 2 squared plus 7. We know that this shifts right and left. And that goes up and down. This goes right and left the opposite. If it says negative 2, we go right, positive 2. If that says this is the same, if that says plus 7, then we go up 7. We already know that. That's in our brains. So when we take a look at this, we see that they are kind of like the same thing inside the parabola, where it says -2 in the x direction, so the center is +2 in the x direction. It says -7 in the y direction, so we know that it's +7 in the y direction. That's the center. And the radius is the square root of 100, which is 10. So let's do this one a little bit quicker. The center of the circle is +5, -8. That's the, okay, it's supposed to be negative. This is supposed to be minus. So this is the same thing as y minus -8. The -8, the -8 right there. So this next one is a nice situation. You should really be able to think about it. So think. You know, what's the what do we have here? What's the plus? What's the plus part? Oh, it's the same thing as x plus 0 squared and, or y minus, sorry, what's the minus part? And y minus 0 squared equals 121. So the center is the origin, and the radius is the square root of 121, which is 11. You can go ahead and hit pause, or maybe you're already done with all of these. Let's see if you are done with all of these. Try to beat me to the end, okay? Try to complete these before I do. The center is -1, -2, and the radius is 1. The center, the x-coordinate is 0, 0, the y-coordinate is 3, and the radius is 7. Here, maybe you got stuck and you have to listen. So the center is -6, 5, and the radius is the square root of 18, which also happens to be 3 square root of 2, but it says round. And it says round to the nearest tenth place, so the radius is 4.2. I hate that it says round. I mean, I really like that answer a lot better. Okay, give the answer in radical form, simplified radical form. So here, the center is 0, 0, and the radius is 8. The center is 4, 2, and the radius is square root of 20, which is 2 square root of 5, which is 4.5. I still like 2 square root of 5 a lot better, because in this class we should be able to simplify radical forms. Center is 0, 0, and the square root of 57. Square root of 57 is 7.5. It does not simplify. That's just rounding, so that's an approximation. That's the approximation symbol. Let's write that clearer. Okay. Write the equation for circles A and B shown below. Show how you arrived at your answers. Okay. Why don't I grab the distance formula? So the distance equals, and I'm going to do A first. The center, 4 minus the point, 6 squared, plus the center, 1 minus the point, 4 squared. Crunch the numbers with the calculator, and we get the square root of 13. Now, we write the equation of the circle. Knowing what the distance is, Knowing what the radius is, this is the radius. So remember, the equation of a circle is radius squared. X minus x1 squared plus y minus y1 squared. Square root of 13 squared is 13, and then x minus 4 squared plus y minus 1 squared. That's the equation for circle A. Well, I didn't leave enough room to do circle B, did I? So let's squeeze it up here on the left-hand side, the right-hand side. So we can do the center minus the point for the x values. Negative 2 minus 1 squared plus 4 minus 8 squared. We have the square root of 9 plus 16 is the square root of 25. I can leave it like that, because if I say it's 5, then I'm just going to go right back. So the radius, remember, we're using this equation right there. So 25 equals, oh, I just realized I didn't write my equal sign over here. So 25 equals x minus negative 2, which is the same as plus 2 squared, plus y minus 4 squared. There it is. Okay, question number 5 is trying to give you a hint about trying to complete the square on this. Well, let me see. Complete the square, we have b equaling 10, half of b equaling 5, and half of b squared equaling 25. So if we take just the x squared plus 10x, and we're going to have to add 25 to that. Now, if we add 25 to that, we're going to have to add 25 there. Why did I do that? We're adding half of b squared. So we added half of b squared. And this factors to be x plus half of b quantity squared. Now let's take that one right there. So we know that b is negative 2, half of b is negative 1, and half of b squared is 1. Bring down that plus sign. If I write it right here, we're going to do y squared minus 2y plus half of b squared plus 1. If I add 1 there, I've got to add 1 there. Add 1 to the left, add 1 to the right. Now, I'm going to complete the square by doing y, and then half of b is negative 1, quantity squared, equals 10 plus 25 plus 1 is 36. So the equation is x plus 5 squared plus y minus 1 squared equals 36. Let's take a look at the homework. Number 1 is really quick and fast, shouldn't take you very long. Which of the following is true about circles whose equations are there? Okay, that is really quick. Remember, the area of a circle is pi r squared. Okay, which of the following represents the equation of a circle shown below? You can do that. Here's a big hint. Try using that point right there. Okay, you can use that point right there, or that one, or that one. By completing the square on each side of the quadratic section, determine the center of the circle. We just did that, okay? You're going to need more space. Remember on number 5, you're going to have to use the distance formula. So go ahead and do number 5. Write down the fact that we are skipping number 6. You can do it graphically if you want, but we're going to skip it. I like things algebraically. This means everywhere you see a y, you can write x minus 3, solve it algebraically, and do number 8. You can do that graphic. If you have any questions, make sure you ask me in class. Have a great night.